Hello, welcome to my channel. Today I'm excited to share an in-depth look at one of my projects, the Environmental Pollution Detection System. This project is the result of my learning journey through the IoT and Robotics course conducted by EDGE in collaboration with the Institute of Information Technology at Jahangirnagar University. In this video, I'll walk you through how this innovative system works, the components involved, and its potential to make a real impact on environmental sustainability. So let's dive into it. Environmental pollution refers to the introduction of harmful substances or contaminants into the natural environment, causing adverse effects on ecosystems, human health, and biodiversity. It includes air, water, soil, noise, and thermal pollution, primarily driven by industrialization, urbanization, deforestation, and excessive waste generation, threatening the planet's sustainability and ecological balance. So for that problem, the primary goal of this project is to monitor and analyze critical environmental factors, including air quality, water contamination, and soil moisture levels, specifically for greenhouse environments. By integrating advanced sensors and real-time data processing, the system provides actionable insights to optimize growing conditions, ensure plant health, and promote sustainable agriculture. Now, let's take a closer look at the key components used in our system. Firstly, an ESP32 board, which is the brain for managing sensors and data processing. Then MQ135 and MQ2 sensors, which detect air quality, CO2, gas, and smoke. GP2Y1010 dust sensor, which measures particulate matter for a QI. Turbidity sensor, which monitors water contamination. YL69 soil moisture sensor, which tracks soil moisture for healthy crops. 1.3-inch OLED display, which shows real-time readings. 4 push buttons, which are for menu navigation. Breadboard jumper wires, for connecting everything during prototyping. And power source, which is USB or battery for portability. And here's the code that powers this entire project. You'll find it shared in the first comment of this video. Now, the moment you've been waiting for the live demo of the project. Here we have a box-shaped structure that serves as the base of the system, where all the components are neatly organized. On the front, we can see a display and navigation buttons, which allow us to view and navigate through the results. There's also a power source made up of 3 lithium batteries and a switch to turn the system on or off. Now, let's talk about the sensors. On one side of the system, we have 2 air quality sensors, the MQ135 sensor and the MQ2 sensor, both designed to measure air quality. At the bottom, you'll notice the ESP32 microcontroller, which is responsible for uploading and running the code that powers the entire system. On another side, we have 3 more sensors, the GP2Y1010 dust sensor, which measures particulate matter in the air. The turbidity sensor, used to check water quality. The YL69 soil moisture sensor, which measures the moisture content in the soil. Together, these components work seamlessly to monitor air, water, and soil conditions. Now let's run the system by clicking the switch. As the system powers on, you'll first see a welcome message, such as Welcome to Environmental Pollution Detection System. Right after that, a menu appears on the display with 3 options: air quality for measuring air pollution, water quality for checking water contamination, soil quality for analyzing soil moisture. Using the push buttons, we can navigate through the menu with up, down, select, and back operations. If we select the air quality option, the system will display a value in ACI air quality index units and provide a status of the air, such as good, moderate, or bad. This is achieved by the MQ135, MQ2, and dust sensor, which work together to measure air pollutants and calculate the ACI value. Now, if we go back to the main menu and select the water quality option, the system will initially show a garbage value in NTU nephelometric turbidity units, along with a status message. To demonstrate, when the turbidity sensor is placed in fresh water, it provides a low value with a status of good. But if we replace the fresh water with polluted or dirty water, the value increases, and the status changes to moderate, poor, or very poor. This process shows how the turbidity sensor effectively detects water contamination in various environments. Finally, if we return to the main menu and select the soil quality option, we'll initially see a garbage value in percentage, along with the moisture status. Now, if we insert the sensor into dry soil, it will show a lower value and a status of dry. As we gradually add water to the soil, the moisture level increases. The displayed value rises, and the status changes from dry to moist, wet, or very wet. Since this is an IoT-based project, I've also integrated an online monitoring system using a software platform called Blink. When the system is switched on, it automatically connects to the internet and uploads all the sensor data to Blink. This means that anyone from anywhere in the world can monitor the system's data in real time, making it highly accessible and convenient for remote environmental monitoring. That's all for today's video on the environmental pollution detection system. I hope you found it insightful and inspiring. If you have any suggestions, feel free to leave them in the comments below. Thank you for watching, and see you in the next video.